status of the jobs and how FireWorks handles that, and if there is a constant query to Slurm or PBS to know the status of the jobs. And the answer to that is no. As we explained, basically, it is the responsibility of the worker. So basically, you have your cluster that queries the database, and it asks the database, do you have a FireWorks that is ready? And the database will answer, yes, I have one. Here it is. So it gives it to the cluster, and so that, and then at that stage, the worker updates. Sorry,
I think it's a bit misleading if you say to the cluster, because I think it's I mean it's your Python, let's say the Python code in FireWorks that actually pulls the job. It will not be directly the cluster to do that.
So it's from the worker.
Command, it's just to clarify that, because I think it might be like then one might be under the impression that it's responsibility of the cluster, but it's really the Python code of FireWorks that pulls the information from the database. But then it's still the Python code of FireWorks that runs the whatever task was assigned to it. And it's still a responsibility of that Python code to keep track of what is going on. At the end, it will update the database with saying, okay, the task that I was assigned has completed or has failed or whatever. But basically it's in charge of this portion of the code that is running on the cluster. So that there is, as David said, there is no central point of control that goes to Slurm or to, let's say, to your job to ask whether the job, what's the status. The status is communicated by the thing that runs the task itself.
One point is that you don't need to worry about that. It's done automatically, and you don't need to implement anything that does that, of course. So that's just to say this is FireWorks. Indeed, it's FireWorks Python code that updates the thing accordingly. That's how it works. Okay. So this is my command line, and this is just to say that to start your Docker, you just run this like that, and then you open the link that you see on the bottom, and then you have a Jupyter notebook. So now I will share the Jupyter notebook. Again, no idea why I cannot share the entire screen. It would have been easier, but unfortunately it does not. So now we have a Jupyter notebook here. Okay, so as you see, there is so I guess you know Jupyter. You have a folder called part 1, so we will go there. And one thing is you have a terminal, so we will open a terminal because it will be useful for some of the things. We don't need the terminal all the time, but it's always good to have one. Then one thing is that you see here, there's an add-on to this Jupyter that allows you to open the Web Gui. So let's open it. And so this is the Web Gui of my FireWorks database for the tutorial at this stage. One thing I will start is basically reset everything. I will come back to this reset just afterwards. So now when you look at what is in there, there's nothing. Okay. So let's go to the quick start. So in this, so this is basically 5 minutes of a hands-on, let's say. We will add a simple workflow to the database with the command line. We will run that workflow. We will see the job status in the FireWorks database, and we will get kind of flavor of the Python API. Okay, So first, as I said, there is a Mongo database running in your Docker. I already resetted it. You saw that by doing reset, it said, oh, are you sure you want to reset your workflow? Please know that this LPAD reset clears everything from your FireWorks database. So this is not something that you will do very often. I mean, you will do it during the tutorial here, but then when you start a project and you are in production, you will not reset your database, or almost never. Okay, but it's important to have something to get it. Another note is that all the FireWorks commands, they have built-in help. So if you do lpad -h, basically you have a list of all the commands that you can do with lpad. And so reset is here. So reset and reinitialize the FireWorks database. And if you do lpad reset -h, you have additional information about the specific command. So now let's first add one workflow to the database using the terminal. So I mean, we can run it inside the Jupyter notebook with the exclamation point, or we can run it through the terminal. I will run it directly inside the Jupyter notebook. So here, we basically add a script that does hello and then goodbye. Okay, so now we can look at our FireWorks database here, and we see that we have a two-step workflow that first should say hello and then say goodbye. Okay. One thing is that we can also get some information on the workflows from the command line with the lpad. So lpad -h, you will see what you can see, you can have. And so you can, for example, do lpad get FireWorks. You get the list of FireWorks that are in your database. Of course, if you have 10,000, you will have 10,000 over there. So you will not do get FireWorks just like that, but you might -s ready to say, give me all the FireWorks that are ready to run, and it gives you that. And those that are completed, okay, there's none. Logic. Okay. Of course, you can look also. So I look at the I looked at the FireWorks, but you can also look at the workflows. So there's one workflow, and if you show everything, you see that it's, so this is the JSON representation of the workflow. You see that you have basically two FireWorks, the hello and the goodbye. Okay, now let's run all the workflow, all the jobs in there. You can do two things. You can do a single shot or a rapid fire. Rapid fire will run everything that is in the database. So let's go. And when you run, you basically have some logging information in there. Okay, getting some. It's creating a launcher directory. It's running the first FireWork in there, and so it's echoing the hello. Just what we asked. It's a stupid task, but it's there. And so at the end, it finished, and then it started the next one. Okay, FireWork number 2, and it said goodbye. Now you can again look at your workflow, and now it's completed. If we look now here and we update our web page, we see that the two FireWorks have indeed completed. So if you click on one of them, you can actually go and get more details. So you have, oops, sorry. So when you click on one, you can click on the identifier of the FireWork, and then you have a full description of the thing. Okay. So this is something I already explained. It created launcher directories for each step. And then we have looked at the Web Gui in here. Now, here we did everything with the command line. So the scripts were added here. This is where you create and add the workflow to the database. But here you can do exactly the same with a Python code. So if we run this Python code, I will explain a little bit what it does afterwards. But basically, it's first resetting the database. This is these first two log messages. And then it's saying, oh, I am adding a workflow. So this is basically this part. When it's adding the workflow, it's saying I'm adding the workflow. Afterwards, when it's doing the rapid fire inside Python, you directly have the jobs that are running at the same time. Not at the same time, one after another. So now a few words about this Python code. So first you have the necessary imports. You have to initialize your launchpad. So this is basically, it contains the information to connect to the Mongo database of jobs. And then when you have this object that has all this information that is connected to the database, it can use the reset command and the add workflow command. Then to create the FireWorks and workflows, you create one workflow from the script task here with hello. We give a name to the FireWork. That's how you get the name here, the hello. It's not extracted from the script task. It's really a name that you give yourself. And then same thing for the second FireWork over there. Then you assemble your workflow, and this is a test workflow. Again, you have your test. I mean, this is the name of the workflow over there. Okay. Now the add workflow stores it to the database, and the rapid fire executes it. So we go through all the three steps that are needed at the same time. This is not something that you do usually. Basically, the rapid fire, you don't put it in the Python code. It's very, but it's just for this quick start. It's to show that you can, if you wish, but it's not something we do. Okay. So for the quick start, it's already finished. Do you have, is there any question that we should answer? Let me just see. So the recordings, I think they will be available afterwards. Annika explained that in the mail, but I guess you will get a mail with the information about this. Okay, so let's continue with the next step. So I close that. Let's go back and go. Oh yeah, maybe I can show you. As I said, the launcher directories, they are over there, but I will not get back to that now. I will go to the now to the introduction to FireWorks. So again, now we will. I mean, it will be even a simpler workflow because it will consist of just a single FireWorks. So we will add a simple workflow to the central database, but now from a file. We will run that workflow in a few modes. You will see that, and we will see about the Python API. Let's first reset our database again so that we have nothing in there. Again, this is not something you will do when you are in production, but for the tutorial, let's do it and have clean things. So the FireWork consists of the fire task and has some specifications, so the options on how to run. Okay. We will first add a given FireWork to the database of jobs with this command. So there is a file called FireWork test here that contains the description. It's a YAML file, so it's easy to read, and it's well structured. it contains the list of things to do, and it's the same, and it's a very easy one. It's also using the script task as before. Script task is a task that is that is already available in FireWorks, and there's a few of them that are, let's say, generic enough to be shared by everyone, let's say. But then when you have an ab initron task or GPO task or whatever task, this is not generic anymore. It's not in FireWorks, but it's in Automate or somewhere else. So this is describing what you do, okay? So now if we add this firework to the database, you get the information that there was a workflow that was added. We've looked at the firework test.yaml file already in there. We'll close it. We don't need it anymore. And now we can again look at what is in the database. Okay, so when you do get fireworks -i1, it says give me the firework with an identifier 1. So all fireworks, of course, have a unique identifier. And because we have a clean database, the first identifier is number 1. So here, a few things are important. The spec contains basically what was in the YAML file. This is basically what needs to be done. It contains the identifier of the firework, and it contains some more information about when it was created and when it was updated, okay? And it contains the state. Okay, it's ready to be run. We did not give it a name, so it's called unnamed firework. If we look at our firework database, the workflow is unnamed and the firework itself is unnamed. Again, this thing here is also accessible through the Web Gui. You click there, and then you click on the identifier, and you have the JSON representation that you have here. Okay. So now let's use our launch to start this, let's say, stupid job. And when we do that, so we see that we have some logging information. The script task started, it completed, and now it's finished. So let's look at our database. It's indeed completed. What was done by the script task is to echo some sentence and to put it to a file, to pipe it to a file. So let's look whether we indeed have this file. Yes, it was created, and it contains the sentence that we had in the firework. Okay. So this is what we have in the file. We have seen that now the state is completed. You now have more information about the launch, what was when it executed. So you don't need to look through that. It's just to say. But when you run one firework, you have a launch of this firework. And basically, if you run it, if you rerun it because maybe the first time it failed, and then you take corrective measures, and then you rerun it, you will have two launches: the first one that failed, and the second one that hopefully completed, let's say. Okay. Now we can try to launch another job. Let's do it. But now we see, oh, there are no fireworks that are ready to run and that match the query. So I cannot do anything. So basically it says the database, I mean, there's nothing that can be run from this database. Okay. So now, I mean, here we are not at the high throughput level yet at all, of course. How do we run many jobs or many rockets? How to do that? We use the rocket launcher, so the R launch, in what we call rapid fire mode. Okay, so let's do again a reset of our database to have nothing else. Again, nothing in the database on the Web Gui. And let's add the exact same job. It's really, again, very stupid, but it's to show the basic concepts here. Now in our database, we have 3 FireWorks ready to be run. Okay, you can look with the command line at what is in the database. So we have the 3 FireWorks that are ready. We can look at just those that are ready, but of course the 3 are ready because they are separate. They are not connected by any dependency. And now we can start them, launch them with the rapid fire mode, which will keep repeating until there is no firework anymore. Okay, so here the 3 fireworks now have all run. Okay, now of course let's look at what happened. This is the file that was created when we ran our launch with the single shot mode, like running just one calculation. And now when we run in the rapid fire mode, you have these launcher directories that are created. And if you look into one, you indeed have your file that has been created. Okay. One more thing is that you also have this JSON file that contains a replication of the information contained in the database. This can also be deactivated if you don't need and you don't want to have many files on the file system. So let's go back. Okay, so as we said, we have added 3 fireworks doing exactly the same thing, and if we look at those in the launch directories, they are all there. Okay, so now one thing is that you still need to do the R launch when you want to submit jobs. You can also do that automatically. So we can basically start a rapid fire mode that will continue to check for fireworks that are ready. So I will basically run that. So let's do a reset again. So we remove the data. Now we start the R launch rapid fire saying that we want to continue infinitely, and we want to sleep 10 seconds between every time we ask whether there is a job to be run, a firework to be run. So it's checking here if there is something to be run, and there is nothing at this stage. Okay, so now let's add one. And now if we go back there, oh, now you see it slept for 10 seconds. And because we added the firework to the database, now it's starting. So you can start, I mean, not the R launch, but I will go back, I will get back to the queue launch, so launching through the queue. You can also do that with kind of that with the queue system. Okay. Again, I mean, now if you look at what is in there, you again see what is in the launch directories. Okay. So let's stop now this thing over there. So again, you have the help information about the R launch command. If you do R launch -h, you have how to run this. So you see that there is a single shot mode, a rapid fire mode, and also there is this additional mode where you can launch multiple rockets basically in parallel. But I mean, I will not get back to, I will not get to this specific mode. In principle, these two should be everything you need to run your calculations. Okay, so one thing to understand is that when you add a firework to the launchpad using lpad, when we do lpad add firework test.yaml, again, the job is just in the database and it's waiting. Okay, it's not submitting jobs to a computing resources. It's just in the database, ready to be run. And then a computing resource must request a computing task by running the launcher, the rlaunch command. Okay, again, it's the worker through this rlaunch command that pulls the job from the database. The thing is, you can actually run this rlaunch command from different locations. So you can have one database, your Mongo database of jobs, and you have 3 different clusters, and you run your Rocket launcher, your rlaunch or qlaunch on the different clusters, and then it will pull the jobs when they have resources and when they are ready. Okay. One thing is, again, you can do that, of course, with Python. It's almost the same Python script as before. So if you run this Python script, it's first initializing the launchpad here, then it's resetting the database. So there's nothing in the database at that stage. And then you create your fire task and firework. You add your firework to the launchpad, and it's also directly launching the rocket. So it should be completed now, okay, as you see. Okay, so at this stage, what we've seen is we stored a simple job, very simple job in the database, and then run it later on the command line. You have also executed multiple jobs with the rapid fire mode. And also we have looked for new jobs automatically while they are inserted in the database using this infinite mode. Okay, so that gives you basically a feeling of how you can automate the things with FireWorks. Okay, of course, we still haven't covered many other important topics. So no complex workflows. This was a 1 step. The previous quick start was 2 steps. And of course, we haven't looked at any material science workflow. We haven't run additional arbitrary Python code or run on different types of computing resources. So for the basic introduction to FireWorks, I am now done. So maybe we can make a quick stop to see if there are questions. I don't know. I mean, and if there are questions in the chat that have not been answered by Guido, then we can answer directly. And if you have a question, just do not hesitate to open your microphone to say. So I'm looking at the question. Okay, I see which part of the code checks for lost jobs. We don't have a lost job at this stage here. I will show that in the next probably in the next tutorial. It will be easier to explain how to do that. Basically, to check for that, you would need to do detect lost runs. Okay, and this is how it works. And if you do detect lost runs now, there's no lost runs at this stage. Okay, but this is the command that you would use if you have a lost run, meaning a run, for example, that was submitted to the queue. So it started running and then it hit the wall time. And because of hitting the wall time, of course, it could not update the status of the database, which is now still running while it was killed by the wall time. And the detect lost runs should detect that. Okay, so then I propose we go on. So let's close this one and go to running through a queue. Okay. So how to launch rockets or jobs through a queue. So for this tutorial, again, Slurm has actually been installed and configured in the Docker. So you can run standard Slurm commands. You can submit a job to the queue oh, I will remove this like that. Okay. So you can run SQ. Let's run SQ. And there is nothing in my queue. Okay. So now we have a very stupid job. Let's see what it is. It's a bash job. It's not. This is not FireWorks. It's just to show that there is Slurm, and the bash job will just say, "Oh, I will sleep a bit. Sleeps for 10 seconds. Now I'm ready to start." Okay, let's. Of course, I'm not in the. So if we submit the job, now when we do SQ, we have the job that is running. Okay. And if you look in your directory where you ran the job, when you submitted the job, there you of course have the standard output of Slurm that echoed the "I will sleep a bit, now I'm ready to start." Okay. Okay, this is of course not FireWorks. It's just to say, no, we are able to use queue launch, the other way to submit jobs, and this is most likely the way you would like to use in production. So basically, there's two ways to do that, and one way is very simple: is you create a job, a FireWorks that submits. But the problem with that is that basically the job is then only the submission, and it would update the database saying that it's completed while the actual calculation itself is still running. So there is another way to do that, is to launch jobs through the queue launch command. So I will not go through these explanations. You can go through them when you get the Docker and how to do it again, or you can also get this information on the FireWorks website. So let's again reset our database. Yes, so we have nothing in our database. I will close that, we don't need it. And let's add a new FireWorks with the command line again. This is the command line. We have added a workflow. We see that it's ready to be run in the Web Gui. And now let's do queue launch single shot. So just before doing the queue launch single shot, I want to explain what is in this workflow. It's piping hello to a hello goodbye.txt, then sleeping for 20 seconds, then piping goodbye to this again hello goodbye.txt. Okay, so if we do queue launch single shot now, it has been submitted to the queue, and if you look at it now, you have your FireWorks job that was submitted to the queue. In your directory where you did queue launch single shot, I mean, this submission script was automatically generated, and this is how it was submitted to Slurm. If you look at this submission script very fast, you will see that basically this is done automatically by FireWorks. Then it goes into the run directory and it launches, and it's using actually inside this, it's doing the R launch. So it will do everything over there. Okay. So here we submitted one single job. Let's make sure that we have our hello goodbye, and we indeed have our hello goodbye because now it's finished. And if you look at that, it's not there anymore. So one thing that I can do now to show you that that basically you can have a running job that hits the wall time, or something else. Let's do the same one. I add again the same script. Okay. Now I have another one that is ready. So let's now do qlaunch single shot. So we have this, and let's do scancel 30. Okay. So now our job started running. Okay. And then I myself canceled it. So this is basically what can happen if you hit the wall time. Now in the database, this job is still running. This is an issue. Okay. And in this case, you can do the LPAT detect lost runs, which you will see will not work in principle. And I will tell you the reason. You need to wait a little bit because basically it's working with a pinging of the database. So basically, when a job is running, every hour it pings the database to say that it's still alive. Okay, and so the detect lost runs basically goes through the database and looks whether the running jobs have been pinged lately. So I might be able to do. So if I say, oh, my pinging was 0, then now I see that I have one lost run. Okay, this is the one. It's still the one. It's the with the ID number number 2. And as you see in the command here, you have that. So now we can do -- rerun. Okay, and now you see that the job that was lost is now again ready to be run. Okay, so this I think answers the question from I don't remember who asked this question, but how to deal with failures. Okay. Okay. So now we see. Okay. Now we've submitted just one job. So now let's submit many jobs at the same time with the rapid fire. So let's add a few of the same again firework. Hello that goes into goodbye.text, and goodbye goes goodbye.text again. And we use the rapid fire mode. So now basically you have the jobs that are submitted and running one, and basically one at a time. Of course, it's fast, but it's just sleeping 5 seconds. So you have we could put more than 5 seconds to see all of them in the queue, but now they have all finished. Okay, as you see here, and if you again do that, you again have the 3 that are completed. And this one did not start. We can submit it. Launch rapid fire. Okay, we run it again. It's submitted, and now there's one that is running. It's one with 20 seconds probably. Yeah, it's the one that I stopped by myself with this cancel. So now it's running. Let's see when it's okay. Now it's completed. The 20 seconds finished. Okay, good. So I think we are at the end of this running through a queue tutorial. So I will now let's take a quick break of 15 minutes, and then we can start again at 12. And while we are doing that, we can have a small discussion if you have questions. I mean, of course, if you're not there, you cannot say. Is there any questions about what was seen up to now? More than what was in the chat? I think we've roughly answered everything that was in the chat. I mean, Guido answered everything. So, okay. I propose we continue, we go on. If there is no further question, so I share again my screen. We have the dashboard here. Let's do an LPAD reset. And now we will go to the next part on the fire tasks. So we'll get to something a little bit more complicated now. So the first thing is we will show how to run multiple tasks within a single firework. And also, this is something that we've seen already, how to run within a Python function, but we'll see it again. So just to make a small recap, in the previous parts, we have seen that we performed a simple script, this one, and this FireWorks was initialized, so created using this YAML file containing the specification of the task to be performed. So as I already said, the script task is one type of fire task. It's a predefined job template written in Python, and maybe you could this could be sufficient for everything you need. But if you start to do more elaborate workflows, you need to create your own fire tasks that do very specific things. Okay, so for that you will have a custom fire task. So you might have an input generation task and an ab init run task or a VASP run task, stuff like that. Okay. Now let's first start with the running of multiple fire tasks. So of course you can run multiple tasks one after another in the same firework, and the first step of your firework might be again to write an input file, and the second step reads it and processes it. That might be the second step is running VASP or running ab init or running whatever code. Okay, and then the third step might move the entire output directory somewhere else on your file system or to a remote server or insert results in the database and things like that. So now let's create a firework that first writes an input file based on a template and for which we have some substitutions that are applied. We will use this built-in, also it's a built-in template writer task that can help create such tasks. So these three tasks are actually tasks that are directly in FireWorks because they are generic enough. The second task executes a script that reads the input file and produces some output. So in our case, in our test case here, what it will do, it will just count the number of words in that file. But it could be anything. You could have, of course, you can have your again your chemistry code, ab init, VASP, GPO, whatever. And then the last one is let's transfer the files to somewhere else. So we will copy the outputs to the home directory using the file transfer task. So just to go to the home directory, we see that there is not much on the home directory except for this launcher. Directory, that was probably there because we did an rlaunch rapid fire in the terminal, but you have no other files in there. Okay, so let's create our three-step firework with Python. So again, we first initialize the launchpad. We reset the FireWorks database. So in our FireWorks at this stage, we have the 5 jobs that were there before. Now we create the first task, which is a template writer task using this simple template, and then it should actually replace this option and this option with these two. Okay, let's look at what is the template task, simple template. So option 1 equal opt1 and opt2. So these two should be replaced. And then the output file will be inputs.txt. Okay, and now the next task should count the words in inputs.txt and pipe this to words.txt. Okay, and last task in this firework is to transfer the words.txt, so the number of words in the inputs, to our home directory. Okay, so we create the firework with the 3 fire tasks. Okay, and we add it to the launchpad. So let's run this. Now we should have just one workflow because it's the one we just created here, and because we reset everything, all the other jobs were cleaned. Okay, so we can actually again play around with lpad to see. Oops. Now we have nothing anymore because I've reset it again. But now, if we do get workflows, what we see, we have one ready. If we look at everything, we now see the spec with the different tasks, and now there's more than just one. There's first the template writer task, then the script task, then the file transfer task. Okay. Now we can submit it with qlaunch. So let's do it here. qlaunch single shot. Oh, let's go to the correct folder. qlaunch. Let's do rapid fire. Okay, it will pull those that are ready and then stop. Okay, so you see now the rapid fire stops because all the workflows, I mean the single one in this case, were completed. So it could not get an additional job to be run that was ready. Okay, so now it's completed. Let's look at the results. So because we did qlaunch rapid fire, it created a block directory inside which there is a launcher directory. Inside this launcher directory, we have all the outputs. So we have inputs.txt, which is option 1.5 and option 2 fast method, which corresponds exactly to what we were asking here. And then what we have in addition to inputs.txt is the words.txt with the number of words, 7. Let's count it. 1 equal is 1. So 1, 2, 3, 4, 5, 6, 7. Very stupid, but just to show the basics. And finally, one of the things that was done at the end was to copy the words.txt to the home directory. So if you look into the home directory, now you have the words.txt. Okay, so you see that we've indeed run one firework with different tasks. Okay, that's one way to do the thing. And this is something that you will, let's say, often do while creating workflows, because you first need to generate your input files for your code, and then you run, and then maybe you transfer the files, you remove the files that are too large, and stuff like that. So you, in one firework, you will line up sequentially the different things that actually you probably, I mean, if you're not doing high throughput yet, you're probably doing that by hand. Okay. Now, one thing is, we have seen how to run multiple tasks in the same firework, but how do we create a custom fire task? So as already said, the template writer task, the script task, and the file transfer task are built in into fireworks, and they can be used to perform a lot of operations. And again, it might be all you need. Of course, the script task can run any shell script, so you could use it like that. But it's probably better if you have tailored fire tasks for your own application that do very specific things instead of calling shell scripts just like that. Okay. So how are we gonna do that? And this is the example that we will take. We will again do a very stupid thing, but it's to show the basics here. We'll create a custom fire task that adds one or more numbers using the Python's sum function. And then afterwards, we will make a workflow out of this new fire task, of course. So just one quick recap of how FireWorks pulls a job. So basically, the basic process is like that. First, okay, this is how the firework is structured, and then in there is a section that contains your task. So this is a list of tasks to be done. And then you have the input specification that will be an input to all the tasks. Then in each task, the second thing that you have is the description of the task. So a JSON representation of the task that has to be performed. If your task is a built-in of FireWorks, it gets it directly. If your task is a custom fire task, you need to do some things to make it work, to actually be able to reconstruct the Python object. One way is to put your custom fire task in a specific folder of FireWorks. Another way is to have your own package that is, let's say, discoverable. So that's how it's done with Automate and Abiflows, for example. Okay. Then the third step at the end of the firework, a firework action is returned that can, and this firework action can make some modifications to the workflow or update the specifications of the next steps. Okay. So let's take our example with the addition task. So what we need to do is we need to add the numbers that are in the input. So when you create a new task, so this is implementing a new task, you have to inherit from fire task base, meaning that it is a fire task of firework. Okay. You can define a specific class variable called FWName, which will say what is the name of my custom fire task, and this is how it will reconstruct the object automatically. It will look for that, and then this is mandatory. You have to implement what needs to be done, and so the firework spec is basically what is passed down to the different tasks. Okay, and so what it needs to do is it takes the input array from the spec, makes the sum, and prints the sum. Okay? And additionally, the FireWorks action will do two things. It will store the result of the sum in the FireWorks database. So this is not the results database. It's just to have some stored data in the FireWorks database as well. This is not something that we do very often, but it's there. So you could use it. And then it will modify the specification of the children, okay, of the next FireWorks by pushing this information to them. Okay. So now we can define a FireWorks that runs this fire task to add the numbers 1 and 2. It's easy. It should give 3 if we are fine. So we look into the fw adder.yaml that is there. Let's quickly stop these things. Go back there. So this adder is basically similar to the previous YAML file, in which we have now the FireWorks name, which is addition task. No parameters, there's nothing there. And then the spec has input array 1, 2. So this is a list in YAML. Okay. Now, if we add this, so we can add it. So this was to add it through the YAML file, but we can do it through Python. In that case, what we do is, again, we take the launchpad, we reset it, and we create a FireWorks using our custom addition task and the specification that is needed. Okay, so let's run that. So now we have our workflow in the database, and we can submit with qlaunch rapid fire, for example. Okay. Now, if we can go to the block and go to the last launcher. Okay, and in there you have the result of your calculation here. The sum of 1 and 2 is 3. Great. Okay. So here we've seen how to devise an addition task. Maybe one thing we can do is make it fail on purpose. So if I do not pass the correct specification, okay, now what do we have? We have one FireWorks ready to be run, okay? And let's go back and do qlaunch rapid fire again. Now you see that your job has failed, of course, because what it tried to do is it tried to do this thing, input array equal FireWorks spec input array, and this was not found. So let's look at our FireWorks. So the exception that was raised is indeed you can see that here. Okay, input array key error. I cannot find input array. Easy. Okay. Okay. So we've seen how to create a custom fire task. Yeah, one thing we might do again, because I haven't shown where it is. Let's do it again one last time. We do a rapid or single shot. We don't need to do more. Okay. And now let's look at what is in there, just to show where it is stored, because we said that the addition task is also storing the sum. You see that there is the stored data here. Okay, we have stored some data in the FireWorks database. Okay. Any additional? I mean, okay. So we finished with the fire tasks. Now, is there any question at this stage? Is everyone still there? Can anyone tell something either in the chat? Okay. I was hoping I was not alone speaking for like 15 or 20 minutes. Okay, so good. Hopefully people are there. Great. So let's now go to the last part of this introduction to FireWorks and get to workflows. Okay. So let's again reset our database like this. And now we will finally learn how to create workflows. So we will basically explore how to connect together multiple FireWorks into workflows. So the simplest workflow is basically two jobs, two FireWorks without any data dependency between them. And the only constraint is that the second job needs to be run after the first one. Okay, so for example, if you take this sentence from Hamlet, you want to have to be or not to be before that is the question. Okay, so this is the diagram of what we want to write down to the terminal. Again, it's a very stupid example, but it's just to show the basics. So let's define and execute this workflow. Now I will go through the Python code to explain how it works. Again, initialization of the launchpad, definition of the task. First task is to write, echo to be or not to be. Second task is to write that is the question. Okay, then we have two FireWorks like that we create. We assemble our workflow that is made of FireWork 1 and FireWork 2. And then after that, we add the connectivity between them, meaning FireWork 1 is a parent of FireWork 2. So this one is a parent of that one. Okay? So let's run that. So we see that now, so we have again reset the launchpad. And if we go to the database, now we have a two-step workflow. We did not give names to the FireWorks, so they're just called unnamed. And if you look at it, the first one here is the thing that it has to do when it runs is to echo to be or not to be. And the second one is to echo that is the question. Okay, and you see the dependency with the arrow in the Web Gui. Okay, you can also again look at the things with the command line like that. So we see that there is one workflow that is ready to be run, and if we display more information, all information, then we have basically the links between things. So parent links. The FireWork 1 is a parent of FireWork 2, and so on and so forth. And so FireWork 2, as we see, is ready. It's the same information here. We have the first one which is ready, the second one which is waiting, and that's it. So now let's do qlaunch rapid fire, but just do one. Okay. Now we see that our workflow is now running. The first firework of the workflow has completed, and the second one is now ready to be run. Okay. We can also look at what's in there. Let's go with the, I think I ran it over there again seconds ago. So let's do this. And in the out, there's to be or not to be. This is the first one that ran. Okay. So let's now do it again. Let's go to the correct folder. Would be easier. Launch. Okay, it's submitted one. I'm stopping. Now, what we see that both are completed. The workflow now is indeed completed, because when a workflow has some fireworks that are waiting or that are ready, it's still running if at least one of them started, one of the fireworks started running. So everything is finished. You can, of course, go to the last one that was submitted, and in there you have, that is the question. Okay. One thing that is I want to explain here, maybe it's good to know. You have, so when you have one workflow, you can access the launch directories of the fireworks. So this is where the first firework ran, and this is where the second firework ran. Okay. So here we are. So we did a simple workflow, like a linear one. This is something, of course, that you could have, I mean, in this case, you could have done it with just a simple echo, of course. And second, you could have done it with 2 fire tasks inside one firework. But this is just, again, to show the basic concepts. Now let's go to a slightly more complicated example in which you have this diamond-like workflow. And in this case, this is basically the organizational chart of a company. So there's the CEO, there's the managers, and there's the interns. And we want to print first, for this diagram, we want to print first the CEO, then the managers, and then the interns. Okay. So how we're gonna create such a workflow? But again, easy to do. This is needed to have the launchpad there. You create the different tasks that do the echo of the sentences over here, right? So you, for example, have Ingrid is the CEO, is the first task. Jack is a manager, Jill is a manager are the 2 other tasks. And the last task is Kip is an intern. We create 4 different fireworks, each with 1 task, which one of these tasks. And we assemble the workflow with their connection IDs. So the workflow is composed of the 4 fireworks there. First firework is a parent of firework 2 and 3. So this one is a parent of this one and this one. So this one can only run when this one has finished. Firework 2 is a parent. So firework 2 is a parent of firework 4. And firework 3 here is a parent of firework 4. Okay, so this means that this one can only run when these 2 have completed. Okay, so let's again submit, well, not submit, add this workflow to the database. Now in our database, we, of course, because we reset it again, we only have our diamond workflow. So you see that the first job is ready. The two others here are waiting for this one to be ready. And this one, of course, waits for these two to be ready. Okay, so now let's do one. Let's first do one at a time. Okay, so now what we see is that the first one has completed. Because the first one has completed, the next two are now ready to be run. Okay, so let's run one of them first, just to show. Okay, and let's look at what's in there. Now, the first one is still completed. It does not do anything else, but this one ran and was now completed. Okay, this one is still ready. It did not run. And this one is still waiting because this one is not completed. Let's add another one. I mean, let's submit another one. Okay, and see what happens. I guess you understand the thing. This one is now completed. And now that these two are both completed, this one is ready to be run. Okay, let's finalize this one, this job, this workflow. Now everything is finished in there. Okay, good. Now let's do this again, but with a rapid fire. Okay, now we did one at a time, but if you do it like this, basically it's submitting the jobs one at a time. And now it's completed. So, and of course you don't have anything in your queue anymore because, I mean, it was a stupid run. Okay, that's it. So I finished earlier than expected with all the basics. I hope it was clear. Again, this first part was really focused on the basics of FireWorks without any mention, let's say, of material science or chemistry. And we will send you information about how to run the Docker so that you can play a little bit with this, because next time, for the second part, you will run calculations with Abinit, well, actually with Abiflows, and you will run some electrons band structure calculations and phonon band structure calculations. You will be able to see, to get to something like I showed in the presentation for the graphene. So you will get up to that point for a simple material, of course. We will take silicon or something. Everything works for silicon, but if we take something too complex, it will take too much time on your own computer. But a small structure should be fine. So I hope things were clear. So now do not hesitate to ask questions. I don't know if there are more questions in the chat now.
The question.